The goal of this project was to construct a ballistic pendulum to analyze a perfectly inelastic collision between two objects. Our ballistic pendulum was constructed by hanging a tissue box with a mass of 39 grams from a piece of yarn 33.2 centimeters long. A tennis ball with a mass of 58 grams was used for our projectile. The constants for this experiment were the mass of the tissue box and the mass of the tennis ball. Variables included the speed of the projectile and of the system before and after the collision, and the height of the system. It was expected momentum and energy would be conserved during the collision. The mass of the projectile and pendulum bob were found using an electronic balance. The velocity of the projectile immediately before the collision and of the system immediately after the collision were determined through video analysis by using data points from the generated velocity versus time graph, and the height of the system was found using the greatest y value generated from the position versus time graph.
The equations were used to determine the momentum the instant before and the instant after collision. It was expected the momentum prior to the collision would equal the momentum after the collision. However, the initial momentum was determined to be 0.279 kilograms times meters per second, and the final momentum was determined to be 0.426 kilograms times meters per second, indicating the momentum increased after the collision. The percent difference between the initial and final momentum is 41.7%. This difference is likely due in part to the fact the ball did not stick immediately to the box upon collision. Thus, the force of the box on the ball as it rebounded may have led to an increase in velocity that in turn led to a gain in momentum. Using the law of conservation of energy, we are able to assume that mechanical energy prior to the collision should be equal to the mechanical energy after the collision. It was assumed prior to the collision the ball traveled horizontally with a constant velocity and was 100% kinetic energy and 0% potential energy, while the pendulum bob was at complete rest and therefore 100% potential and 0% kinetic energy. It was expected that the energy would be conserved as this was designed to imitate a perfectly inelastic collision. However, the energy found prior to the collision was 0.6696 joules and after was 0.23765 joules, indicating a severe decrease in energy. Because the pendulum bob was a tissue box, air resistance is the most likely source of this decrease.
Using a similar setup as before, the kinetic energy of the projectile immediately before collision and of the system immediately after collision were compared, and a decrease in kinetic energy was expected. Instead, the results indicate an increase in kinetic energy, which again is likely due to the force of the box on the ball as the ball rebounded inside the system immediately after collision. This force may have contributed to a greater velocity and in turn an increase in kinetic energy. In this experiment, we learned how to apply the principles of energy and momentum in a perfectly inelastic collision and analyze experimental setup and design for error analysis. Given the results generated from this experiment, future alterations to the design would be to produce a projectile and pendulum system where the projectile sticks to the bob to eliminate potential rebound as a source of error.